So, a PV site assessment really has a foundation in which you must mentally solve and work your way through. So, here's what I have. I've got two options for you to think about and go over when you're modeling the philosophy and going over how to construct a system here. A prevalent thought that a lot of folks use and think about when they're doing their PV site assessment is option A. Very first thing you do, you find what the customer's kilowatt hour usage is over the year. You find what their budget is that they have available. And then you find the location of the array, and based upon their goals, determining how many kilowatt hours per year they'd like to offset. That is question number 4, and that's section 1.0 that you heard on the previous couple of videos. Then once you get to that, we need to determine the size of the system that it will offset. That incentive that you find to offset, that PVDC, which is module rating, raw size, is then what you're going to use to estimate the cost of the system of the cost range. So let's just say a client has $7,000 that they have available to them and they want to offload 50% of their electrical needs. And as a typical U.S. resident, that's about a 5K system. Well, there's no way in the world $7,000 is going to buy them that system. And so what you can do when you're doing this option for site assessment and system sizing, and this is really for site assessing a system, is to say, okay, based upon $7,000 in your location that you have available on this roof, you could probably do, looks like a 2 kilowatt system. And now you could give them a base, that analysis as step 2, which is then what you put into the PV site assessor. Hey, based upon a 2 kilowatt system, that's the thing that we want to have happen, and what we want to do is go over that basis there. So now that we know what the familiarity is, what they are interested in, that's what you size the cost analysis on. Because I know eventually we're going to have to use some financial calculators to get there, and they're going to require you to have very specific pieces of equipment listed in order to solve that problem. That's a tough order, especially for many of us that don't know all the equipment, what's available, what the contractor has available at his or her disposal. So that's a problem. Once you get to that idea of what their system size is from step 2 and step 3, run the energy periscope. Try to find the best of fit for the cost and size of the system. So make sure, though, that in the energy periscope, for example, that you've documented all of what you're thinking about using. Now, the customer will not get that, but what you can keep in your back pocket is you can run using any number of energy model calculators. You keep that report on hand, and let's say ABC Solar comes out and they decide to do that install. They know that there was a home site assessment. They may contact you and say, hey, we know you did that. We can offer them the ABC Solar this solar site assessment and maybe give that contractor, that installer, a copy of the software system to calculate based upon some very common run-of-the-mill type of PV modules and inverters. So that's option A. Option B is the approach that I like to take. Maybe it's just because I'm more scatterbrained, or maybe because I like being able to build things dynamically, or I'm just screwed up. Let's go with that option, option B. So very first thing, start the site assessment report. Get through the steps, get over to calculations, get to that 6.2 section. Find out exactly what their DC wattages are that help offset. So basically, you talk to the customer, you get to that question 4, which is in section 1.0. They say, hey, I'd like $10,000 to be applied, and I have a need of 50%. Run the site assessment, get to 6.2, run the numbers, put them in, and then come up with an idea for what they are looking at. Now, when you are with that client and you're at their home, you want to start talking to them about systems. They may have a preference. I like a string inverter now that I know more about it, or I like a microinverter now that I know about it. So once we know about those issues, maybe we can make a best case analysis using Energy Periscope or any of those other associated programs to give you a very good value and number to hit. So that gets me to step 3. You now have an idea of what 6.2 talks about. Use, say, Energy Periscope and design a system. Now, this is only between you and Energy Periscope. It's not what's going into the site assessment. You create a system based upon the parameters of run-of-the-mill pieces of equipment. Now, again, this is a PV site assessment, so this is why I'm doing it in the audio format, because I can have plausible deniability on this point. very common modules that you would see are Kyocera. You've got some older Kyocera, then you've got Evergreen solars out there. You've got a lot of other grape solar. But here's what I recommend. Kyocera, maybe the BP. Go to a company like Sun Electronics. Go to their website, see what models are out there, and then get an idea of what the costs are for those. And choose a model right now about 230 watts. That seems to be a common module that's out in industry. And then choose an inverter that's common. You've got Sunny Boy. You've got, from the larger sides of things, you've got Schneider Electric. You've got Enphase on microinverters. And I'm just drawing the names, continue on and on. But the point is, you want to find an inverter system that is common, easily found. Go to Alt-E, for example, their website, or go to any internet search engine and find modules that are common. Try not to go off the beaten path, and make sure you find a good UL-listed quality product. And then build your system there. Now note that the site assessment will not contain any of that information, but it's a realistic number because it's based upon realistic pieces of equipment. So I like option B because I've got realistic items. I've done some installs. I know what's common. For us being new, we don't know what's common. So I would say microinverter system, there's a couple that are out there, and string inverter, there's a couple big companies that are out there, and then use a 230 watt module as just a rough guideline for it. Don't get an 100 watt module. We're not talking about installs here. That's not our point. Our point is to use some data that will get us to a better answer. Once we have that energy periscope values created, then we can enter that into step 3 and run the report consistent based upon that size system. I'm going to run through in the next video a site and talk about all the points and bring all of that home. But this is just the option to think of how the complete system needs to go. What steps do you like to use to determine how to go about system sizing and financial calculations?